Welcome to Ask and Learn.
Hey, it's Clarissa. So we're given f of x as theta g of x, and g of x is theta of h of x, and we're proving that f of x is theta of h of x. So by the definition of the big theta notation, f of x is O of g of x, and f of x is omega g of x, and g of x is O of h of x, and f of x is omega g of x. So by the definition of the big O notation and the big omega notation, there then exist constants C1, C2, C3, C4, K1, K2, K3, K4, such that the absolute value of f of x is less than C1 absolute value g of x whenever k is bigger than 1. So I'll write all of these. So this one's the first one. Whenever x is bigger than k of 1. And we have absolute value of f of x. This one's a bit different. Excuse me. This one contains C2, g of x. Whenever k is bigger than x is bigger than k2. This one's g of x is smaller or equal to k3, h of x whenever k is bigger than x3. And this one's g of x is bigger or equal to c4 absolute value of h of x whenever x is bigger than k4. So let k equals max, k1, k2, k3, k4, and let x is bigger than 0. So we have absolute value of f of x is less than or equal to c1 absolute value g of x, which is less than or equal to c1 c3 h of x, which is equal to c1 c3 h of x. And then we have f of x absolute value is bigger or equal to c2 g of x, which is bigger or equal to c2 c4 h of x, which is equal to c2 c4 h of x. By the definition of the big O notation, f of x is O of h of x with constants k equals max k1 all the way to k4, and c equal to c1 c3. And by the definition of the big omega notation, f of x is omega h of x with constants k equals max from k1 to k4. And c is equal to c2 and c4. And by the definition of the big theta notation, f of x is then theta h of x.